So now look here, the trend of tendency for the formation of ionic compound in the periodic table. In a periodic table, when you move from left to right, that is along the period, ionization energy increases. Electron affinity also increases. Why ionization energy increases? Because when you move from left to right, the atomic number increases, which means that the nuclear charge increases. And in order to compensate the nuclear charge, the electron is added to the same subshell. So the distance between the outer electron and the nucleus is not changing, and because of the high attractive force, the size of the atom decreases. And as the size of the atom decreases, the outermost electron comes closer to the nucleus. Hence, it is very difficult to remove the electron.
Sir?
Yes, ma?
Screen
Yes.
is not visible, sir.
Screen is not visible. I'll make it. Is it visible now?
Yes, sir. Thank you, sir.
So when you move from left to right, the ionization energy increases, and also electron affinity also increases. When you move down the group, atomic size increases by the introduction of new orbits. So ionization energy decreases and electron affinity also increases. So what happens? At the left, less ionization energy. At the right of the periodic table, high electron affinity. So when the ionization energy is less, they are metals. Their character is electropositive. On the right side, they are non-metals. Their character is electronegative. The electropositive elements, alkali metals and alkaline earth metals, can be taken as examples. And for electronegative elements, halogens can be taken as example. You look here, a metal becoming metal plus electron. This is first ionization energy. From the cation, one more electron is removed to form a dication, which is the second ionization energy. So the tendency to form cation by the group 1 metals is greater than that of the group 2 metals. The reason is, for group 1 metals, simply the removal of one electron is sufficient. So they will form a unipositive ions. But for the group 2 metals, you have to remove 2 electrons, where the removal of the second electrons becomes much difficult because we have already formed a cation. So removal of an electron from a neutral atom and the removal of electron from a cation, they are much different. So as the second ionization energy is very high, the tendency to form cation is greater in the case of alkali metals when comparing that of the alkaline earth metals. So similarly, if you take the halogens, addition of electron, it is electron affinity. You take group 6 and group 7 elements. See the group 6 element, oxygen, sulfur, selenium, tellurium, polonium. Oxygen on the addition of one electron becomes O minus. It is minus 140.9. And O minus, you are adding one more electron because you have to form O2 minus. So addition of electron to an ion which is already negative is much difficult. So it becomes a plus 0.7 plus 769.9. See, the first ionization, first electron affinity is negative. The second electron affinity is positive. That is why formation of oxide or sulfide is not so easy as the formation of halides. So halide formation is easier, but oxide or sulfide formation is very difficult. That is why the question may be asked like this: why alkaline earth metals have less tendency than alkali metals to form ionic compounds, or why formation of halides easier than oxides? The questions may be asked like this. I suppose you understand everything. Is it clear?